In 2022, 29% of remote capable workers, those whose jobs could be completed from home, were working fully remotely, as observed in a recent Gallup survey. Gallup predicted that the proportion of remote workers would decline in 2022. Suppose researchers conducted a follow-up survey and in a sample of 150 remote capable workers, 35 were working fully remote. We can use this statistical tool to respond to this question. Conduct a one-sample z-test at a 5% significance level to determine if there is enough evidence to suggest a decline in fully remote workers. So we will have to use this. We will ask not for confidence interval, but for a significance test. And we'll deal with the number of successes. The sample size was 150. The number of successes is 35, 35 workers. They anticipated, or the null was that 29% would be working, but they predicted that it would shrink so that it would be less. So this is a one-tailed test because it's less. And the z-value is negative 1.53. The probability of a z-value of negative 1.5295 or 1.53 or less in this tail is 0.0631. We would need to see a value less, with a probability of less than 0.05, a value closer to 1.96. In order to say that indeed, based on their observations, there's a significant difference between this probability and that probability. But we do not have that. That p-value, 0.0631 percentage of observations, 6% of observations are down in that tail. And that's just a little bit too much. Is there enough evidence to suggest a decline in fully remote workers? No, there is not enough evidence to reject the null. The estimated value of 0.29 is still reasonable. Is there enough evidence to reject the null hypothesis? No.